was a mistake here. Okay, so let's fix that. Okay, so in question 22, okay. This will be A, this will be B, this will be C. Okay, so I'm right here. A, no. We start with C. C squared is equals to A squared plus B squared. So 41 squared equals to 9 squared plus 40 squared. So this is 81 plus 1600, which will give us 1681. Now, if I do 41 squared in the calculator, that should give me also 1681. So here is 1681. So because they're equal, this triangle is acute. No, I mean is right. Okay, so we will say this triangle is a right triangle because C squared is equals to A squared plus B squared. Then what else are we supposed to say? Justify. Okay, we've justified our answer. We also need to justify here. So the other part we should have known, we should have started with A plus B is greater than C. A plus C is greater, subspace. A plus C is greater than B, and B plus C is greater than A. Then I take another pen. A is who? 9, and B is 40, and then this one is 41. So this inequality is true because I'm adding 9 to 40. That makes it 49. And 49 is bigger than 41. So this is 9 plus 41. That makes it 50. And 50 is bigger than 40. This is 40 plus 41. Already 40 is bigger than 9. So whether I add to it or not, it will be greater. This side will be greater than that side. So then you write your other justification. Determine whether each set of measures can be measures of the sides of a triangle. You say A, B, and C can be measures of the sides of a triangle because all my inequalities are true. Okay? So all this is your answer. You have to, all this is the answer to part 1. So this question has 2 parts, okay? The part that you're supposed to justify whether the sides make a triangle, that is question 1. And then question 2 is to classify. And how are you supposed to classify? You need to use one of these. Not all, one of them. One of them is the answer to your work, according to your work, okay? And there is the answer to the second part, okay? All right, we move on. Now here we are supposed to do what? We are supposed to write a 2-column proof. Okay. Now, here is where we are going to use the converse hinge theorem and Pythagoras theorem. Okay? All right, so let's start. Okay, we go here. We make 2 columns. Here, this will be statement. and here this will be reason. Here you will write all your given. Your given is all this. You see all this? All this. You will put it over here. Write it there. Then the next step, we know that d squared plus e squared should give me x squared because of Pythagorean theorem. So d squared plus e squared should give me x squared. Why am I doing this? Pythagoras. Pythagorean theorem. Okay? Then I know that I can substitute this with f. Okay? How do I know that? Because the same thing here. Same thing here. Okay? So you look at this triangle here, I will write f squared, because it's the bigger side, must be greater than d squared plus e squared. Now, because I have this, I would replace this here. Okay? So then I'm going to write f squared is greater than x squared. Like that. I mean less. Why am I saying greater? Less. Because these two must be less than this less. Okay? Now, I want to know if I want to know the value of f. So if I want to know the value of f, I will square root both sides. Square root both sides, I will get f is less than x. Okay? Let me write it 2 times. Wait. Okay, let's replace this. Then let's do here square root of f squared, because we have to justify this part. Okay? So now, because I want to find f, I need to square root. And if I square root on my left, I must also square root on my right. So this gives me f is less than x. Okay. Now, here we substituted. Substitution. Who did we substitute? dE. We replaced dE with f squared. Okay. Then here we are wanting to find the side length. Yes. And the side length can only be gotten by the square root and the positive square root. Remember, we discussed in class the square root of a number will always be plus or minus. So if I do square root of 4, my answer is either positive 2 or negative 2. Now, these are lengths. These are lengths of a triangle. And lengths can never be negative. So we want only the positive square root. So here we will write finding the positive square root. Okay? Here we will write finding the positive square root. Okay. Then I have finished talking about that. What else can I talk about here? This angle here. I have to say something about angle M. Angle M is equal to 90 degrees. It is a right angle, because that's the kanun for right angle. All right, let's continue. Can I erase this so we can do another jadwal here? Okay. So here is statement. Here is reason. Okay. Now that I know that angle M is 90 degrees, I also know angle F, this angle here, okay, must be less than this angle here, okay? Angle F must be less than angle M, okay? Why? Because of the converse hinge theorem. This is converse hinge theorem. Converse hinge theorem. Okay? What does the converse theorem says? The angle opposite the longer side. Okay? Yes. This one is an acute angle right here, because we don't have the 90 degree and it's not bigger than 180. So therefore it has to be less than this angle here, because they're corresponding. This and this corresponds. Okay? All right. So let's continue. So then we know that angle M is who? 90. So I can write here angle F has to be less than 90 degrees. And that is called what? Substitution. When you replace a harf with a rakam, you write substitution. Or when you replace a rakam with another rakam. I mean, when you replace a harf with another rakam, then it will be substitution. Okay? So now, if angle F is less than 90, then it has to be acute. Okay? So then that means angle F, because angle F is less than 90, then it must be an acute angle, because all acute angles are 90 degrees, are less than 90 degrees. Okay? So then what does that mean? Angle D is less than angle F. Okay? How do I know that? This angle here is smaller than this. And this side here is shorter than this. Okay? So remember, if you're following the long side, then you're the biggest angle in that triangle. Okay? If you're here and you're going to the long side, then that means you are the biggest angle in that triangle. Okay? So angle D is less than angle F, which also means angle E is less than angle F. Okay? Less than angle F. Okay? So that's that canon. If one side of a triangle is longer, okay, and we can explain that. You see, this is one long side of this triangle. So therefore, who is the angle that is opposite it? M. M is the biggest angle in this triangle. Okay? Same thing that we explained over here. F goes to the longer side, DE. Therefore, that means angle D must be smaller than angle F, and angle E will also be smaller than angle F. Okay? So if one side of a triangle is longer than the other side, the angle opposite it, the angle opposite the longer side, must be, yes, will be, must be, should be, all this you can use. Must be bigger or larger, whichever one, than the angle opposite the short side. Okay? Like that. I need more space. I have two things to write. Let me see. Okay, I'll continue here because the same question. Okay. So we're going to write here statement, and then reason. Then now we're going to say angle D is less than 90. This angle here. Then angle F, no, angle E must also be less than 90. Okay. Then that means angle D, because all these three are less than 90, and angle F. Okay, that means also angle F, angle D is less than angle F. Okay. Now, so that means D and E are also less than angle F. Okay. Because angle F was also less than 90. Okay. Remember this angle we said over there was less than 90. Remember here, see, we had said here, angle F is less than 90. So, because now we have 3 halves, we're going to use transitive property. So, transitive property. Okay. Then that I have proved that this is an acute triangle. So let me write triangle D, E, F is an acute triangle. And then that's definition of acute. Definition of acute triangle. Okay. Then let's do this one. This one will be an obtuse triangle. I already see because angle C here is greater than 90 but less than 180. Okay, so we draw our jadwal. We write here statement and reason. How do I know? Says write a 2-column proof. Okay. All right. So our given is already over there. I'm not going to write it again. So just copy it from the question and you put it over here. So this is given. This, right? All this given here. All this. Put it here. Okay. Now, who do we have? A, B, and X. Okay, let's do Pythagorean theorem. A squared plus B squared equals to X squared. That's Pythagoras. Pythagorean theorem. Okay. Then we can substitute. A squared plus B squared, C squared. And then this one will be greater than X squared. So that is substitution. So C is the longer side, and it will be greater than this and this squared. And this squared is the same as X squared. Okay, that's what we just did over there. All right, so then what do? We find our sides. So we do C squared, X squared. To find sides, we must square root and get the positive square root. Okay, so finding the positive square roots, because sides cannot be negative. Okay, then what else do I know? Now I need to talk about angle V. Angle V is equal to 90 degrees, and if you are equal to 90 degrees, you are a right angle. Yalla, yalla, yalla. So this here is statement. This one here is reason. Okay. Now I need to do some substitutions and converse hinge theorem. So that means angle C is greater than angle V. You can clearly see this is more than 90. Okay? So, and which theorem? Converse hinge theorem. Converse hinge theorem. Okay, allows us to write this kanun. Then, so that means angle V is 90, so we substitute. Angle C must be greater than 90 degrees. That's substitution. Substitution. Okay. Now, I know that angle C is less than 9, is greater than 90 degrees, but it is less than 180 degrees. This is obtuse. This is the definition of obtuse angle. Okay? Obtuse angle. Therefore, triangle ABC is an obtuse triangle. And here you write definition of an obtuse triangle. Okay. Now, construction workers are building a marble sidewalk around a park that is shaped like a right triangle. Right there, draw it, right triangle. Draw your right triangle. Okay. Each marble slab adds 2 feet to the length of the sidewalk. Okay. So this is my sidewalk. So it is saying from here to here, la. From, yes, well, the same thing. So this will be added here, 2 feet. And then this is 2 feet from here to here. This is 2 feet from here to here. So all this white space from the red space is 2 feet. Okay. Let's continue. The workers find that exactly excuse me, exactly 1,071 and 1,840 slabs are required to make the sidewalks along the short sides. So, 1,071, 1,840 slabs. So here the unit is slabs, no longer feet. Okay? And you're not counting the corner pieces. How many slabs? So I don't need to worry about the feet. Why am I worried about the feet? Because the question told me to use slabs. So I will use these rakams. Okay? So this is my B and this is my A. How do I know? A is always smaller than B. And it really doesn't matter. You can put anything there. How many? I mean, you can put A and B, wherever, but you should use that kanun. A is always smaller than B. Okay. How many slabs are required to make the sidewalk that lands along the long side? So that means this is C. We want C. C equals the square root of A squared plus B squared. There you go. 1,071 squared plus 1,840 squared. Just like that. And then you make sure you show all your steps. Put this in the calculator. That should give you, how much should that give you? 4, 5, 3, 2, 6, 4, 1. And then when you find its square root, the answer is 2,129. How many slabs? Slabs. And you box your answer. Okay? Just like that. Okay, let's go to the next question. Triangle XYZ is a 45, 45, 90 triangle with right angle at Z. Okay. So Z is where the right angle is. And we've been told it's 45, 45, 90. Okay. Find the coordinates of X in quadrant 1. Aha. Now you need to know how to label. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. You have learned how to label your coordinate plane since grade 3. You cannot forget that. Okay? Now we want our answer to be here. That's what it says. Okay. Can I sketch? Yes. Let me sketch before I continue. So I know that either my triangle will look like this or my triangle will look like this. Or my triangle will look like this. Depends. Okay? Okay. All I know that Z has to be here at the 90-degree angle. That's all I know. It can also look like this. So this is me thinking. Okay? Now, the question says, y is -1, 2. So -1, 2 is here. -1, 2 is here, and that is y. Aha. And because they have the same y, I know this is going to be a horizontal line because my y's are the same. So that means they are all cutting here. So 6, 2 is 1, 2, 3, 1, 2, 3, right here. Okay? So 6, 2. 1, 2, 3, 4, 5, 6. Okay, and 2 up. Aye. So therefore, my graph will either be this. Yes, because I don't think I'm going down. If I go down, my answer will not be in the first quadrant. So my triangle has to be this triangle. So all this go away. I erase this. See how thinking is important. Okay. So because this is a 45, 45 triangle, we know that this is X and this also has to be X. So the raqam from here to here should be the same as the raqam from here to here. That much I know. So I already have 1 here, 2, 3, 4, 5, 6, 7. So I already had 6 over here, and now I had 1 more, so that's 7. So that distance is 7. So that means I need to go up 7. 2, 4, 6, 7. There you go. Now I am going to draw my line here and put 7 here. And remember, this has to be x square root 2. Okay, but I really don't need that. I just needed this point. So this is y, this is z, and this is who? X. Because the question said find the coordinates of x. So now, what is this point? This point is 6. And then let's count. 2, 4, or let's go by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 6, 9. That's my answer. Just like that. Okay? All right, let's move on. This is a 30-60. Okay. This is a 30-60, 90. And who is angle Z? Angle Z. What do we want? We want G. So find the coordinates of E. Okay. Find the coordinates of E. We have G and F. So now, see, this angle here, I mean, this point has the same X as this point. So this is a vertical line. That's how I know. Okay, let me start by labeling quadrant 1, quadrant 2, quadrant 3, quadrant 4. Then we're talking about 30, 60, 90 triangle. Okay. So my triangle has to be like this. And quadrant 3. So that means I am going here. I'm going to this side. So my triangle will be somewhere here. Okay. All right. So let's draw this. So who is at 90? Angle F. Yes. So angle F is at 90. Angle G is going to be above angle F. So this has to be angle E. Now, we have been told FG is the longer leg. FG is the longer leg. FG. So therefore, this is 60 because this is 90. And this is your 30 degrees. Okay? Now, let us find what's the distance from here to here. That should be -4 minus 2. And that will be, then you find the absolute value. Or you just count the boxes. From -4 to -2 will give you 6. Okay? So this distance here is 6. Okay? All right. So now let us find. Okay, let me leave this here like that. Now let me draw another one here. So this is 60 degrees. This is E. This is F. And this is 30. Okay. And this is 6. Now, what do we know about a 30, 60, 90? We know that this will be the shorter side, so that will be x. And we know this will be x square root 3. And this will be 2x. Okay? So, we need to find what is x. So, I will use this to find what is x. So, I know that the long side is written as x square root 3. And the long side is also 6 units. Okay? Now to get x, I will divide both sides by square root of 3. So this goes away. X becomes 2 square root 3. So that's what I will write here. 2 square root. Okay. 2 square root 3. Now I can come here and write it here. 2 square root 3. Okay. All right. So now let's draw our triangle. We know that F is at -3, 4. 1, 2, 3, 4. No. -3, -4. 1, 2, 3, 4. So this is F. Okay? -3, -4. Then we know that G is -3, 2 here. This is G. Okay, then I draw my line. Now, because E, according to this picture, is on the left of E. If I'm going to the left of E, I must minus. Okay? Let's say I want to get this point here. What will I do? This is who? -3. I am going to the left of it. I will minus how much? 1, 1, 2, 3, 4, 5. So this will be -8 because -3 minus 5 should give me -8. Now let's confirm if I am true. 0, -1, -2, -3, -4, -5, -6, -7, -8. Do you see that? Because I went 5 spaces to the left, because I'm going to the left, I have to minus. Okay, so I have to use the same rule. I have to use the same rule to find E. Now, this here is -3 also, okay? It's still on -3. And I am going this way. How many units? I am going this way to square root 3 units. So to get my other point for E, I must minus this from this. So I will write here, E equals -3 minus 2 square root 3. That's the X value. Then the Y value will stay the same because it will be with F on the same Y line. And the F value is who? -4. Just like that. The question says find coordinates of E. Okay? Now, and that should be my answer. There is my answer. Because they didn't tell me to make it as a decimal, so I'm going to leave it like this. So here is my answer for E. Okay? All right, let's move on. All right, in question 43, we can use 60-30 rule. Because if this is the 90 and this is 30, this has to be 60. Now, according to the question, Melody is in charge of building a ramp for a loading dock. According to the plan, the ramp makes a 30-degree angle at the ground, with the ground. The plan also states that ST is 4 feet longer than RS. So I can write it 4 plus X, X plus 4. So this is X. Okay. Okay, all right, let's move on. This should be 2X. All right. Okay. Use a calculator to find the length of the 3 sides of the ramp to the nearest 1,000. Okay. Now, we also know this is the longer side. So the longer side is the same as X square root 3. Okay. So then we're going to write here, longer side equals to X square root 3. We also know that the longer side is X plus 4 should be, then it should be equal to X square root 3. We substitute. Then what do? We subtract 4 on both sides. We subtract X on both sides. Because this has X, it is friends with this X. So to move this to be with the friend, I have to nagus. Nagus X, nagus X. Okay, so this is 4. And then here we're going to have X square root 3 minus X. And who is my greatest common factor? X. X is here and X is also here. So we write X outside and then square root of 3 minus 1. If I taksim X square root of 3 with my greatest common factor, okay, let's do greatest common factor. So X square root of 3 is the same as writing X times square root of 3. And X is just the same as writing X. So my common factor is who? X. I write it here outside. Who is remaining? 3. Who is not remaining? Nobody. So I put 1. And because there's minus here, there should be minus there. Okay. And that should equal to 4. Then, who are the rakams? This and this. So I want X. I will taksim here with square root of 3 minus 1. Like that. on both sides. Square root of 3 minus 1. This goes away. So now I have x equals, and we agreed we cannot have square root down. In the denominator, we cannot have square root. So I want to change my answer to a decimal. I should get 5.464. Well, the question said I need thousands. So 4 and then square root 3 minus 1. 641. So to the nearest thousands, I circle this, I underline this, I'm not adding. So my answer should be 5464 feet. Okay. Then now I want to find who. Use the calculator to find the length of the three sides. Okay. So then I need to do this part. Okay. So we found RS, which is the shorter side, which is equals to x, and x is 5.464 feet. So that's my first answer. Now I want to do ST. ST is equals to x plus 4, which is 5.464 plus 4, which gives me 9.464 feet. Okay, that's ST. Then I want to do RT. RT is 2x, which is the same as 2 times 5.464, which will give me 8, 12, 9, 10. Okay, feet. And you box your answer. Okay, so there. Use the calculator to find the length of the three sides. So you should have 3 answers. Here are your 3 answers. Okay. All right. Let's go to the next question. Liling is making a quilt. She starts with 2 small squares. Okay, these ones. Then she arranges the 4 square. She cuts the along the diagonal. She cuts them here. That's what that means. Okay. Then she arranges the 4 resulting triangles, triangle 1, 2, 3, and 4, to make a larger square quilt block, this one. Okay, she arranged them and she made this one. She wants the large quilt to have an area of 36, okay? Area of a square equals to side squared. Area of a square is who? 36 equals to side squared. I want the side. I will do square root of both sides. S is 6. I'll put 6 here. I'll put 6 here, 6 here, 6 here. Okay? Now, remember this is a 45 degree angle because it's a square. This is 90 and you're cutting it into noose. So this is 45 and 45 degrees. And if that's 45, this has to be 45, this has to be 45 because this is 90 and this is 90. So that's what happens, 45, 45, 90, like that. Okay? Then we continue. What happens? After I do that, now I can. So this is now the hypotenuse. See this part here? This part here is this part here. Is that part there? Okay? So that's the C. It is directly opposite the 90 degree. So, so let's do the triangle. We're going to do it this way. It doesn't matter how you draw the 90 degree triangle. So this is 90. We know that this is 6. And we know that this is 45 and 45 degrees. What do we know about the 90, 45, 45, 90 triangle? We know this is x, this is x, this is x square root 2. Okay? So now, if I want to find x, this will help me. So what do I say? That's my now next step. So I'm going to say hypotenuse is equals to x square root 2. And hypotenuse is also 6, so x square root 2. For me to find x, I will divide by square root 2, divide by square root 2. This goes away. X is 3 square root 2. Okay. Now I know that this here is 3 square root 2, and this here is 3 square root 2, and this here is 3 square root 2, and this here is 3 square root 2. Okay. I'd. What are the side lengths? What side lengths should Lilling use for the two small squares? Oh, I could have done that also a different way. I could have used Pythagorean theorem for the big triangle. Find this C here and then divide that C by 2. Yeah, I could have done that. I could have done that. If I didn't want to use the 45 degree, I could have just used this triangle here, the big one. So it will be like this. And I know this is 6 and this is 6. So I want to find C, but then after I find C, I have to divide C by 2. So C equals the square root of 6 squared plus 6 squared, which is 36 plus 36, which is equals to the square root of 72. Okay. Then I will divide the square root of 72 by 2. Let's see if we are going to get the same answer. Square root okay, then divide by 2. Yes, I get the same answer. So see, two different ways of doing the same thing. Either you use the 45 degree or you use Pythagorean theorem. Same way to get that. Okay, here is our answer for the x. Okay, now let's continue. What are the side lengths Lilling should use for the two small squares? Then you write your sentence. Lilling should use 3 square root 2 as the side length of the two small squares of material. Now we need to explain. So you explain using this. Say I use the 45, 90 Kanun, or I use the Pythagoras theorem. And if you use the Pythagoras theorem, remember to say you divided the long diagonal by 2 to get the side length, like that. So that's your explanation, okay? Then it says here, explain any assumptions that you make for part A. So, what assumptions can I make? First, I have to make sure that the triangles are 45, 90. Okay, that's one thing. So that's my first assumption. The triangle must be 45 degree 90 triangle. Okay, that's my first assumption. Because I cut a square into 2 equal, and I must cut equal. I must also cut must cut equal parts. Okay. And the parts must be with minimal error. So I cannot just use a scissors. Well, I can use a scissors, but I have to be very careful. I would prefer using a laser cutter. So I must use a laser cutter. I must use a laser cutter to get the exact or minimal error. Like that. We want something with a minimal error. Okay? A laser cutter to get the precise. I think precise should be the best word here. Precise. Precise. Cut. Or precise dimensions. Precise dimensions. Because if there is just a slight mistake, you will not be able to join like this. Okay? Then, what is the next assumption? Or when joining, because now you remember you're cutting these pieces. So you have to join them to make this bigger part. So that means you must glue them close. The seam must be very, very small. Okay? So you use glue or you use very tiny stitches. Okay? So here's my last assumption. When joining, I should make the smallest seam, either by joining, what am I writing? By joining with glue or smallest, tiniest stitches. Tiniest stitches. Like that. Okay? All right. Here we have been given a trapezoid, an isosceles trapezoid. And they've asked us to find the perimeter of ABCD. Now, this is 90. And this is also 90 because this is a rectangle. So, and if this is 135, what is 135 minus 90? This is 5, 9, 10, 11, 45. So this is 45 here. And therefore, if this is 45, this has to be 45, and this is 90. So this is a 90-90 triangle. This is a good question. Okay. So then, opposite sides of a rectangle are congruent. And if this is a 45-degree triangle, the legs must be the same. So therefore, this is 7 and this is 7. And if the whole of this is 7, this has to be 13. And if this is 13, this is also 13. Because 7 plus 7 is 14. 14, or you do 27 minus 14, which will give you 13. That's how I know that. Okay? Then I want to find this side. I can use Pythagoras theorem, or I can use, so let's do DC. I can do DC two ways. I can use, this should be x square root of 2, right? And our x is 7. Because remember, this is x and this is x because this is 45, 45, 90. Okay? So I can either use the 45, 45, 90 rule, or I can use Pythagoras theorem. Okay? So I would say DC is the same as x square root 2, and x is 7 square root 2, like that. So I will put here 7 square root 2. If I don't like this rule, I can use DC equals the square root of A squared plus B squared, which is 7 squared plus 7 squared, which is 49 plus 49, which is 7 square root 2. If you put that in the calculator, you should get 7 square root 2. Okay? So therefore, 7 square root 2. Now what the question wants? My answer as a decimal, and it wants perimeter. Aha. This is a trapezoid, an isosceles trapezoid. A trapezoid has 4 sides. Perimeter means add all the sides. Perimeter. So we do AD plus DC plus CB plus BA. Okay. AD 27. DC 7 square root 2. CB 13. This other one 7 square root 2. 27 plus 13, those are friends. That should be 40. So, yes. 27 plus 13, 10, 3, yes, 40. Okay. Then this should be 14 square root 2. Then if you put this in the calculator, you should get 59.748. 798, not 748. 798. Then the question told us to the nearest 10. The 10th digit is, the digit in the 10th place is 7. Then the 100th digit affects it. Is this digit 5 or more? You said yes. You increase this digit by 1. So your answer is approximately 59 and 8/10. No units. So you write here, just units. Like that. That's your answer. Okay? Why are some right triangles considered special? Yes, there's 30, 60, 90 triangle and the 45, 45. Because I can solve without, I don't need a calculator to solve this. To solve a 45, 45 degree and 45, 45, 90 degree. So triangle, 45, 45, 90-degree triangle and a 30, 60, 90 triangle. So this is a 45, 45, 90 triangle, and this is a 30, 60, triangle. Okay. Now, when I say I don't need to use a calculator, because I know this has to be x, and this has to be x, and this is x square root 2. And I know this has to be x square root 3, this has to be x, and this has to be 2x. If I know x, I can solve the rest of the triangle just by knowing x. Okay? I don't need a calculator. So, why are some right triangles considered? Because some right triangles are considered special because they have a special rule for it, or a specific rule to solve it. Okay. To solve it without using a calculator. Just like that. And you make sure you draw, you label all this. Okay? Okay, what is happening here? I have two people, Carmen and Audrey. And what do they want? They want to find this value of x. I know this is our, what is this? An equilateral triangle. This triangle here is equilateral, okay? See? And what does that mean? All the angles are 60 degrees. All the interior angles are 60 degrees. And this is 60, but it is bisected. Remember, this is the altitude or the angle bisector. So bisector means you cut it into two equal parts. So that's 30, that's 30. See? Now that I know this is a 30, 60, 90 triangle, and this is 2x, okay? So this, I don't like this x here. Okay, so let me put m. So I don't have to use that. So this will be m here, and this will be m square root 3, like that, okay? This is better. Now, I want to find m, okay? So hypotenuse is 2m. Hypotenuse is also 6 because I found it there. So to find m, I will divide both sides by 2. M is 3. So with another color, I'll put here 3. Now to get this, I should just do 3 square root 3. And that's my answer. Okay? All right. Now, Carmen is correct. Carmen is correct. Okay. So there is my work. Okay. Then we want long leg. Long leg equals to m square root 3. And that is 3 square root 3. And who has 3 square root 3? Carmen. Explain your reasoning. Okay. X is the long leg. X is the long leg. Okay. I divided the hypotenuse. Oh no, first that this triangle is, yes. This triangle is a 30, 60, 90 triangle. Okay? And x is the long leg. I divided the hypotenuse by 2 to get the short leg. To get the short leg. Okay? After I got the short leg, I multiplied it by the square root of 3 to get the long leg. I multiplied the short leg 3 by the square root of 3 to get the long leg, just like that. And there. So, who is correct? Carmen is correct. Carmen is correct. So, the first part is who is correct. Okay? So, there. Carmen is correct. Explain your reasoning. All this is your explanation. All this is your explanation to your work. Okay? Let's go on. The ratio of the measures of the angles of a triangle. 1, 2, 3. This is a 30, 60, 90. Why? because the short legs are not the same. So that's how I know. Okay, so this is 1, this is 2, and this is 3. So this is the 30 degrees, this is the 60 degree, this is the 90 degree. This is short leg, this is long leg, and this is hypotenuse. Hypotenuse. Okay? All right. Now, I draw my triangle. This is 30. This is 60. This is 90. This is x square root 3, 2x. Then what do I know? I know the shortest side is 8. This is the shortest side, 8. So this will be 8 square root 3. And this should be 2 times 8, which is 16. Okay. What is the perimeter of the triangle? Hey, perimeter. It's the easiest question. Side 1 plus side 2 plus side 3, 8 plus 8 square root 3 plus 16, 24 plus 8 square root 3. Round your answer to the nearest tenth. Put this in the calculator. What do you get? 37.8564. Well, we don't need all that. To the nearest tenth, this is the digit in the tenth place. This is the digit that affects it. It is 5 and more, so I will add 1. My answer should be 37 and 9/10. We don't have units, so we write units. So we box our answer. Okay, let's go to here. Draw a rectangle that has a diagonal twice as long as its width. Already that is a 30, 60, 90. Because the diagonal is twice the long as its width. The width is the shorter side, and the diagonal is 2x or 2w. That's a 30, 60, 90 triangle. Because it's a rectangle, okay? Then you know that this is the length, this will also be the length, this is the width, this will also be the width. We want this. So since I don't know the width, I will use the half x. Well, so this is 30, this is 60, this is 90. And we've been told if you use x here, the diagonal is twice as long. That means 2 times. Okay, and this we know is what? X square root 3. All right, write an equation to find the length. We want to write an equation. Really? I cannot use the 30-60 rule. Okay, let's use Pythagoras theorem. Let's use Pythagorean theorem. So I know this is A. I shouldn't, this is still black. It looks almost like black. This is A. This is B. I want to find B, and that is C. Okay, I want to find B. Let's use Pythagoras theorem. C squared equals to A squared plus B squared. C squared is 2x, and I want to square it. By the way, I should get this. If I don't get this, something is wrong. And then my A is x squared plus B squared. Okay. Now, this becomes 4x squared. How does it become 4x squared? Because 2x times 2x 2 times 2 is 4. X times x is x squared equals to x squared plus b squared equals to x squared plus b squared. Now to get b, I must minus x squared on both sides. Okay. This goes away. That gives me b squared, and this gives me 3x squared. To get b, what should I do? I should square root both sides. Okay. What does this mean? Square root of 3 times square root of x squared. I can only solve this, which is x. So my answer here is b is x square root of 3. And because b is x square root of 3, b is the same as the length. So then we can write here, don't box this, because we want the length. So we say the length is the same as b, which is the same as x square root 3. And now that is your answer. Okay. So you can use Pythagoras theorem. You can use 30, 60, 90. But the best one is Pythagoras theorem. Yes, because we don't know what the angle is. Okay. But according to me, I clearly saw it is a 30-60 angle. Use Pythagoras theorem. That's the best. Okay. Okay, who is here? Okay, so these things are called trig ratios. Sine, cos, tan. And we must do this 2 different ways. One for angle L. I mean, we should have answers for angle L, and we should have answers for angle M. And how should we write our answers? As a ratio. As a fraction. Okay, so these ratios the answers must be as a fraction and as a decimal. And if you write the decimal, it must be to the nearest hundredth. Okay. So now let's start with this. We will start with angle L. So this is angle L. This is the opposite. This is the hypotenuse because it is always opposite 90 degree. So this is the adjacent. Okay. So for us to do the trig ratios, we must remember SOHCAHTOA. That is important. SOHCAHTOA is going to help us to get. So here, the first one is sine L, then cos L, then tan L. Okay? And to get sine, we must do opposite over hypotenuse. Opposite over hypotenuse. To get cos, we must do adjacent over hypotenuse. Adjacent over hypotenuse. Or divide. To get tan, we must divide the opposite and the adjacent. Okay? What's the number for the opposite? L. Who is L? 15. What's the number for the hypotenuse? N. What is N? 39. Here, it will be 12, or it will be 36. 36 over, oh, okay, let's do this. It's easier when you write it here. L is opposite, adjacent, and this is hypotenuse. So it's easier. So after you label OAH like that. So H is what? 39. O is 15. A is 36. Then you simplify these using your calculator. When you simplify, you should get here 5 out of 13. And then here you will get 12 out of 13. And then here you should get 5 out of 12. Then you change them to decimal, okay? So when you change this to decimal, whatever answer you get will be rounded, and then you put this approximately because you rounded to the nearest tenth, 38. And then here, you approximate that, you get 0.9, no, here, 0.92. Okay, and then here, you should get 0.42 when you round. You should know rounding by now. Okay, 5 divide 13 is 0. You want to the nearest tenth, so you just need the first three numbers, first three digits. Actually 2 digits, not 3. So circle that, underline. What do we want? 100th. Oh, sorry. 100th. So yes, that's why you need 3 digits, because it says 100th, you need 3 digits. So you circle that, you underline this, we are not adding, so here is your answer. Okay. All right, 12 over 13, you get 0.923. You circle the second digit, you underline the third, you're not adding, so this is your answer. Okay. 5 divide 12, you get 0.416. You circle this, you underline that. That's how you end up with this, because you increase this by 1. Okay. Then now, here we are going to do for M. Okay. So sine M, cos M, and tan M. Okay. I don't want to write the canon again. But then I know this is OAH for M. How do I know? I go back here. I raise what I had done for L, because now my theta is M. My theta is here. So this is opposite. This is adjacent. And this is hypotenuse. Okay? So my numbers. O over H. O over H will be 15 over 39. Why is it the same? Should not be the same. No, should not be the same. No. My opposite is M. So here is my O. See? And then my L is my adjacent. And then my N is my hypotenuse. Yes. Please be very careful when you're doing that. Okay, so 36. O is 36. H is 39. There you go. Then cos is what? Adjacent over hypotenuse. My adjacent is 15. My hypotenuse is 39. And tan is opposite over adjacent. Okay? Opposite of adjacent is 36 over 15. Okay. So this becomes 12 over 13. That becomes 5 over 13. And this becomes 12 over 5. Okay. Now, look here. You see this? You put it here. You see this? You put it here. And this is the flip of this, your reciprocal. Okay? You flip that. Once you solve this, it's easier for you to do this. Look, I don't even need to write all this. This sign goes here, and this cos goes to the sign over here. They are the same. Sine L is the same as cos M. Cos L is the same as sine M. And then these two, you flip. Whatever is here, you flip it to get the other one. Flip. Okay? Then you already did the decimal here. See? Your work is just to look. I keep telling you, math is easy. Make connections. I don't have to keep on using my calculator all the time. Make connections. Make. Here, this should be 6. No, not 6, 2.4. What am I doing? 2.4. So do you flip this? See? But how? No. Here, use the calculator or do it long division. Do not. This one is equal because you can divide. There is no approximate there. This one is definitely equal. These ones are the approximates because you have to round. Okay? All right. Okay, so what do we do here? Sokato. So, let me write it here. So, so I want opposite, hypotenuse, adjacent. Opposite, adjacent, hypotenuse. Then I do the one for M. Opposite, adjacent, and this is hypotenuse because it's opposite here. Okay, so then we're gonna do here sine L, cos L, tan L, sine M, cos M, tan M. Okay. Opposite of a hypotenuse, adjacent of a hypotenuse, opposite over adjacent. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay? And then you put your numbers. 12 over 24. 12 square root 3 over 24. 12 over 12 square root 3. Okay? So this becomes half. This becomes something over 2. Square root of 3 over 2. And this becomes 3 square root of 3 over 3. Remember, square root cannot be down, cannot be in the denominator. So these are your answers for your fraction. Now, remember we said this comes here, so half, and this goes there. Square root of 3 over 2. And then this will be, and we said 3 over square root 3, but we cannot have this, so this changes to oh no, let's do it the best way. Let me help you. So this becomes 12 square root 3 over 12 because we said we're going to flip this. So then you cancel this and cancel that. So that's how you're remaining with square root of 3, just like that. Okay. So here the answer is square root of 3 as a fraction. Okay. This you should know as a decimal, 0.5, 0.5. That you should know as a decimal. Okay. Then this one will become 0.87. By now you should know how to round. This becomes 0.58. Okay, put it in the calculator and practice rounding. So this should go here, 0.87. And then do this in the calculator. That should give you 1.73. Okay. Approximately. This one is equal. This one is approximately 1.73. Back your answer. Your answer. Okay. All right. Same thing here. Sine R, cos R, tan R. Here, sine S, cos S, tan S. Okay. So, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Sine R. This is opposite, this is adjacent, this is hypotenuse. So opposite is 16 over 34. Adjacent is 30 over 34. Opposite is 16 over 30. Okay. Let's do for sine S. S is opposite is 30. Adjacent is 16. 34 is hypotenuse. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay, so this is what opposite is 630, 34. Yes, so remember, that goes there. Then this is 16 over 34. And then this is 30 opposite over adjacent, 16. Okay. Simplify your fractions. When you simplify, you should get here 8 over 17, 15 over 17, and 8 over 15. So therefore, this should be 8 over 17, and this should be 15 over 17, and this should be 15 over 8. Okay? And when you do the decimal, this should be approximately 4,700. This should be approximately 8,800. This should be approximately 5,300. So this goes here, approximately 8,800, approximately 4,700. This one you do in the calculator, you should get 1 and 8,800. There you go. Let's move on. Okay. Sine J, cos J, tan J. Sine L, cos L, tan L. So katoa. You should not forget this kanun. Don't forget opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay, let's do J first. Opposite, adjacent, hypotenuse. Hypotenuse is always opposite the 90-degree angle. Opposite is the one that is farthest away. The one that is very far away from it is opposite. Closer to it is adjacent. Okay? Then let's put our outcomes. Opposite for J is 12. Hypotenuse is 20. Adjacent is 16. Hypotenuse is 12. No, it's 20. Then opposite is 12. Adjacent is 16. Okay? Same thing you write here. 16 out of 20. 12 out of 20. 16 out of 12. So let's confirm our numbers for L are correct. This is adjacent because it's closer to L. This is opposite because it is far away from L. And this is hypotenuse because it is opposite the 90-degree angle. Now, opposite is 16, hypotenuse is 20. I'm correct. Adjacent is 12, hypotenuse is 20. I'm correct. Opposite is 16, adjacent is 12. I am correct. Then you simplify. So this should be 3 out of 5. This should be, who is the common denominator? 4. So 4 out of 5. And then here the common denominator is also 4. So 3 out of 4. 3 out of 5 should be 0.6. So equal, not approximate. This should be 8/10, and this should be 75 hundredths. Now, look here. It says to the nearest hundredth if necessary. So these ones, if you want to write them to the nearest hundredth, you just put 0 here. But you don't need, because it says if necessary. So you can leave them as 10th. Okay? Then what did we say? This fraction comes here. This fraction goes here. And this one, you find the reciprocal, which is that. Okay? Then this is 8/10. This is 6/10. This has to be an approximate because 3 is not a factor of 4 or a multiple. So this one will be 3 because it's a repeating decimal. Okay? So there, those are your answers for that. Okay. Here we don't need a calculator, so we just need to use a triangle, special right triangle. So this is 60 because it's going to the longer side. It's 90, and this is 30. And I know that this will be x square root 3, this will be x, and this will be 2x. And I need SOHCAHTOA. And I want to find sine 30. So this is opposite, this is adjacent, and this is hypotenuse. Sine 30 equals to opposite over hypotenuse. And opposite is x, and hypotenuse is 2x. And I divide this, I'll cross this out, and I cross this out. Nothing is remaining, I write 1. 2 is remaining down here. Write your answer as a fraction and as a decimal. My fraction, my decimal. Alas. Here I am going to do the 45 degree. So 45, 90 triangle. This is x, this is x, this is x square root 2. I want tan of 45. Tan, I need opposite and adjacent. Opposite and adjacent. Okay, so tan 45 degrees is opposite over adjacent. X divide x, which is 1. As a decimal, well, I don't know why we need to write it like that. Same thing as a fraction, like that. There you go. Okay, now we need to do cos 60. So we're going to do 60, 30 triangle, 60, 30, 90 triangle. So if this is 60, this is my 30, this is my 90, this will be x square root 3, this will be x, this will be 2x. I want cos. I want adjacent, which is this one here, and hypotenuse, okay? So cos 60 is adjacent over hypotenuse, x over 2x. This goes away, this goes away. Nothing remains up here, half. If nothing is remaining, you write 1, okay? And then this is your fraction. And your decimal with. And you know what you can say? Sine 30 is the same as cos 60. Sine 30 is the same as cos 60. That's a canon you should have in your brain. Okay? So if you write here nous, you should write here nous. That's what I'm saying. Okay? Always. That's the canon. Sine 30 will always equal cos 60. Always. Tan 45 will always equal 1. Always, always. Tan 30 will, sine 30 will always be half. Cos 60 will always be half. Always. These are canons. Okay? Okay, so we draw our triangle. We put 60, we put 30, we put 90, we put 2x, we put x, x square root of 3. Same thing, 60, 30, 90, x square root of 3, x, 2x. We put 45, 45, x, x, x square root of 2. Okay, what do I want? Krakatoa. I want to find my trig ratios. Sine is opposite over hypotenuse. Tan is opposite. Tan of who? 30. Opposite over adjacent. Okay. Here, cos adjacent over hypotenuse. Okay. So let's do that. Sine 60 equals to opposite over hypotenuse. Opposite is x square root 3. Hypotenuse is 2x. This x and this x goes away. Square root 3 over 2. You put that in the calculator. You should get 0.866 to the nearest hundredth. So that will be 0.87. Okay, put tan 30. Tan is opposite over adjacent, x over x square root 3. This x and this x goes away. You get 1 over square root of 3. Remember, square root cannot be down in the denominator. So that becomes square root of 3 over 3. And then This is your answer as a fraction. Oh, we needed an answer as a fraction. Okay, then we need our decimal. Put this in the calculator. You should get, what should you get? 0.577. So square root of 3 over 3 is 0.577. Circle the second digit because it says hundredth, and then add 1. So this becomes 5 and 8 tenths. Okay. Now here we want to do cos 45 degrees. Cos 45 degrees. Cos is adjacent over hypotenuse. X over x square root 2. This goes away. This becomes 1 over square root 2, which is 2 over square root 2 over 2. Okay? And then therefore this is your fraction. And then change square root 2 over 2 as a decimal. You should get 707. Then you do the rounding, circle the digits on the second place, and then the digit to the third place affects your circle. If this is 5 or more, you add 1. If it is not, you leave it alone. So then the answer here is 7100th, and you box your answer. Okay. Okay, what do we want to do? Find the value of x. This is what? Opposite. And this is who? Adjacent. So we use tan. So we have that. So tan 64 equals to what? Opposite over adjacent. Opposite is who? X. Adjacent is who? 11. And here you have tan 64. Okay. Multiply 11 both sides. This goes away. X equals to 11 tan 64. You put this in your calculator, you should get 22533, nearest hundredth. Circle the digit in the second place, underline the digit in the third. This is not 5 or more, so I'm not adding. My answer should be 22 and 55 hundredths, and you box your answer and you put units because you want to find the length from here to here. Okay? Let's do this. We want to find that. So we have hypotenuse and we have adjacent. So we're going to use cos because cos is the one that gives us that. In SOHCAHTOA, cos gives us adjacent and hypotenuse. So we're going to write here cos 29 degrees is adjacent over hypotenuse. Then cos 29 degrees is x over 29. Then what do? We multiply both sides by 29. And okay, I was about to get confused. I was like, why do I have the same number? Okay, so that will be 29 multiply cos 29. Put this in the calculator. You should get 25,363 hundredths. We are not adding. 25 and 36 hundredths. And because it is length and we don't have the unit, we just write units. Okay. We have 41. This is the hypotenuse. This is the adjacent. We write SOHCAHTOA to remind ourselves who is adjacent and hypotenuse cos. So we write here cos 41 is adjacent over hypotenuse. X over 32 gives me cos 41. To get x, I have to multiply each side by 32. This 32 and that 32 goes away. X equals to 32 multiply cos 41. Put that in the calculator. That should give you 21, no, 24, 150. Circle the digit in the second place, underline the digit in the third place. The digit in the third place is less than 5, so we are not going to affect this digit in the circle. So that will be 24 and 1500. Okay. Okay. What's happening here? Sean used a surveying tool to map a region of land for his science class. To determine the height of a vertical rock formation, he measured the distance from the base of the formation to his position. So that means Sean is standing over here. Sean is over here. Okay? That's what that means. All right. He measured the distance from the base of the formation to his position and the angle between the ground and the line of sight to the top of the formation. Okay. The distance was 43 meters and the angle was 36 degrees. What is the height of the formation to the nearest meter? I want this. So this is adjacent and this is opposite. Oh, okay. Very good. Opposite. So I want the opposite. So I write SOHCAHTOA. SOHCAHTOA. So who do I use when I have opposite and adjacent? I use tan. Okay, so then we're going to write here tan 36 equals to x, so equals to opposite over adjacent. Now tan 36 opposite I don't know, so I will put it as x, and adjacent is 43. Now to get x, I will multiply both sides by 43. So this goes away. So then I can write here x equals to 43 multiply tan 36. So then put that in the calculator. That should give us 31,341 to the nearest meter. Circle, underline. To the nearest meter means to the nearest whole number. Nearest whole number. That's what to the nearest meter means. So our whole number is all the digits before the decimal. And it's going to be affected by the digits in the 10th place. This digit here is not 5 or more, so we're not going to add. So the height is approximately 31 meters. We need a sentence. What is the height of the formation? The height of the formation is approximately 31 meters. What's your answer? A 60-foot ramp rises from the first floor to the second floor of a parking garage. The ramp makes a 15-degree angle with the ground. How high above the first floor is the second floor? So they want this here. They want here is your x. So this is opposite. This is opposite. And this will be hypotenuse. And then SOHCAHTOA. So we use sine. There you go. Opposite and hypotenuse. Okay. Okay. How high? So that's what they want. How high? Height is vertical. How high above the first floor is the second floor? So we're going to write here sine 15 is equals to opposite over hypotenuse. Sine 15 is x over 60. Then we multiply by 60. We multiply by 60. This goes away. X is 60 sine 15. I don't know what to do here. I know what to do here. I need to put this in the calculator. And you should get 15 and 15 and 5 to 9. Then we want what? To the nearest tenth. See, you should always keep going back to the question to read and check. Always. You solve 2 steps, you read again like that. Okay? So this is an approximate. So this will be 15 and 5/10. Do we have units? Yes, feet. See? Now, what does the question want? How high above the first floor? Okay. The second floor is 15 and 5/10 feet high above the first floor. That's the answer to your question. Albert is helping to build a set for a play. No, Albert is helping to build the set for a play. So this thing is called a set. I guess they need it on the stage, okay? One piece of scenery is a large triangle that will be constructed out of wood and be painted to represent a mountain. Albert would like to know the area of the piece of scenery so that he can buy the right amount of paint. What is the area of this triangle? And round your answer to the nearest tenth. Kanun for area of triangle, area equals A times B. Because I don't know the height, so we will use this kanun. A times B sine C divided by 2. Or you can write it as half times A times B sine C. You can write it this way, you can write it this way. It's up to you. Same thing. Nothing changes. Now, so this is C. Then it doesn't matter what you put where. Put A here, B here. The angle must be the half if it's not labeled for you, okay? So then who is your A? 10. Because it is here. So this is small a, this is small b, this is small c. So times b, which is our 8 sine 34 degrees, and you divide by 2. Okay. So you should get 22 and 36 hundredths to the nearest tenth. Circle the 10th digit. The digit in the 10th place, underline the digit in the hundredths place. The digit in the hundredths place is 5 and more, so we will increase this. So our answer is 22 and 4/10. Is there units? Feet. square feet, because it's area. So square feet, just like that. If you want to do it this way, half times 10 times 8 times sine 34, you should get the same number, 22 and 36. 22 and 4/10 square feet. Okay? Same. All right. Terence and Rodrigo are trying to determine the relationship between the angles of elevation and depression. So I know definitely angle of elevation must be the same as angle of depression. Why? Because they are alternate interior angles. Angle of depression, angle of elevation. And this is parallel to this, and this is a transversal. So I know these two are always going to be congruent. Terence says that if you're looking up at someone with of elevation of 35, then they are looking down at you with an angle of depression. Oh, that is definitely wrong. La 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 la. Mafi true. Terence is la. Which is the complement of 35? La 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 la. Rodrigo disagrees and says that the other person will be looking down at you with an angle of depression equal. Sir, yes, angle of depression lazim be the same as angle of elevation. Explain your reasoning. I explained my reasoning. Alternate interior angles. So, who is correct? Rodrigo. Rodrigo is correct because angle of elevation must be congruent to angle of depression because they are alternate interior angles. And alternate interior angles are always congruent. And my picture has explained. There, all this is my work. Okay? That's how you explain your reasoning. Draw diagrams, use canoons, use math vocabulary. Okay? Lazim. How we discuss in class is how you should explain your answer. You must ensure the examiner you know what you're talking about. Use vocabulary, be proud of your work. Okay? Draw neat diagrams, write neatly, all this. A classmate finds the angle of elevation of an object, but she's trying to find the angle of depression. Write a question to help her solve the problem. Okay. So many questions you can write. So many. Are the angles of elevation and depression different in measure? That's one. Okay. Another question you can write are the angles of elevation and depression corresponding angles. And then here you're going to write Aisha says the angle of depression is 2 times the angle of elevation minus 180. Just make up your own question. Is Aisha correct? Explain clearly. So that's what this question is asking you. Write a question to help us solve the problem. You have 3 different questions. One of them is okay. Okay? It's up to you. Right? See? Thinking. You lazim must think. Classify the statement as below as true or false. Explain your reasoning. As a person moves closer to an object he or she is sighting, the angle of elevation increases. I think this is true. Let's see. So my object is here. Okay? This is my object. And now this is me here. Okay? So this angle here is smaller. As I'm going towards my object, this angle becomes bigger. Okay. See? As a person is moving closer to an object, the angle of elevation increases. This is a true statement. This statement is true. Okay? And how do you know it is true? The closer you move, the bigger the angle. Yes, because you are reducing this distance. You see this distance here? It was here now, sir. Now it is only from it was from here to here, and now it is only from here to here. So it's becoming smaller. The closer you move towards the height, the bigger the angle of elevation. So if I move here again, see, this angle will be bigger than that. Okay? So this statement is true because the closer you move to the height, you are making the horizontal distance to reduce your, is that even English? You are reducing you are reducing you are reducing the horizontal distance. Okay. And when you reduce the horizontal distance, you're increasing the angle. The statement is true because the closer you move to the height or to the object. Yes, to the object. Okay. Closer to move to the object. You're reducing the horizontal distance, hence making the angle of elevation to be greater. That's what that means. Oh, ho, 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 ho. Aha. I remember this question. I told you guys to do, and only a few of you shared your answers with me. Okay. I see 2 right triangles. I see 3 triangles, but only 2 of them are right. I see the bigger right triangle and I see the smaller right triangle. Now, if this is 70 and this is 90, this must be 20. And this must be 160. And this must be 5. Okay? Degrees. 60 degrees. Okay. Now, here, let us use. Here we are going to use similar triangles. Let's use similar triangles first. Okay? So I'm going to draw my small right triangle. Let's label. I always tell you labeling is important. B, C, D. So this is my small triangle. This is BDC. BDC. And this is 90. And this is 70. And this is 20. Oh, okay. I don't know DC. I can put it as choose any half, doesn't matter. Put here M and put here N. I don't know both of them. I don't have a rakam here and I don't have a rakam here. Okay. Now let us draw the bigger right triangle. So the bigger right triangle, this is A, this is B, this is C. So this will be M plus 2. So from here to here is M. So to get this, I will do M plus 2. And this will still be N. Okay? And this will be 15, and this will be 75, because I want both of them. Okay? Just like that. Okay. Then, what can I use? SOHCAHTOA, because it's a right triangle. So, SOHCAHTOA. Now, I will use 20 and I will use 15. So we should do here for the small triangle. So we'll do tan 20 is opposite over adjacent. Opposite over adjacent. So this is opposite. This is opposite. And this is adjacent here. So that will be N over M. Same thing for this side. Tan 15 is opposite over adjacent, which is N over M plus 2. Up to there, we are good. Actually, let me write it here. I don't want to misuse my space. I don't know what happened. Okay, let's just draw this again. A, B, C, 160, and this is 5. And this is M, and this is N. So this is the small triangle, the small right triangle. So this is 20, this is 70, this is D, this is B, and this is C. This is M, and this is N. Then we'll draw the big right triangle. This is A, this is C, this is B, this will be M plus 2, and this will be N. Then we said we're going to use SOHCAHTOA. Okay, so we're going to use tan because tan is the one that gives us, we have adjacent and we have opposite of 20 degrees, okay? And here, this is 15 and this is 75. So we're going to use 15. So this is adjacent and this is opposite, okay? So step 1, since we said we're going to use tan 20 degrees is opposite over adjacent. Opposite is N, adjacent is M, and here I have tan 20 degrees. So I can also do tan 15, which is N over M plus 2. Okay? So now, I want M. Let's find N. Let's find N. To find N, I will multiply here by M, and I will multiply here by M. So this goes away. And to find N here, I will multiply by M plus 2, and I will multiply here by M plus 2. So this goes away. So now we can write N is equals to M tan 20. And here, N is equals to M plus 2 tan 15. Then we can do distributive property. So here we have N is equals to M tan 15 plus 2 tan 15. Okay, distributive property. Then this N should equal to this N, okay? Because they're the same half. So let's substitute. So we say here N is equals to N. So we're gonna, let's use a different color. So on the right, M, this degrees, okay? M tan 20 degrees should equals to M tan 15 degrees plus 2 tan 15 degrees. This and this are friends. So I will move this here. How? By minusing. So subtract both sides. Subtract both sides by M tan 15. M tan 15. This goes away. So then I have 2 tan 15. And I have here M tan 20 minus M tan 15. Make sure you put the degrees, okay? 2 tan 15 degrees. Now what do you notice? Greatest common factor is M. Take it outside. Tan 20 degrees minus tan 15 degrees is equals to 2 tan 15 degrees. I want M. I will taqsim both sides. I will divide both sides with tan 20 minus tan 15. Tan, put it like this. Tan 20 minus tan 15. Okay. So this cancels. Now I will have M. Okay. And if I put this in the calculator, I should get 5 and 5/8. But the question wants me to the nearest tenth. Okay. So this And then 5, approximately 5 6/10. Okay, so I put that here. That's my M. 5 6, or I put it here, 5 6/10. But then this becomes plus 2. So 5 plus 6/10 plus 2 becomes 7 6/10. So this is 7 6/10. Okay, then I can find N. I can either use this kanun or I can use this kanun. I'm going to use this. So let's find N. N is equals to 5.6 tan 20. So if I put this in the calculator, what do I get? I should get 2 and 0 3. 2 and 3/10, 300ths. 2 and 300ths, which is almost 2. Okay, which is 2. So N is 2. So I can put 2 here and I can put 2 here. But I want AB. I want AB. AB, so I will use Pythagorean theorem. So I want this distance. So this is C. So, okay, so let's find C. C equals the square root of A squared plus B squared. I agree. What is my A? 7.6 squared plus 2 squared. And then I find the square root. And that should give me 7.847. 7.847. And then the question says round to the nearest tenth, circle that 7.8. Do I have units? No. This is my answer. Okay. But there is an easier way of doing this also. Huh? There's an easier way of doing this. Okay. When I erase this, erase all this, I show you an easier way of doing this instead of doing all these steps. Okay. I will leave those numbers that way. This halves I'll take away. Okay. And I will not use trig ratios. We'll use something else. Quickly. Okay. Now let's do this. Now what do you notice? You notice that I have ABCD. I'm going to use triangle ABD to get my answer. So let's draw triangle ABD. It is like that. Okay. So this is A, this is B, and this is D. We know that this is 20. This has to be 160 because this is a linear pair. Okay, they must be supplementary. So this is 160 degrees. The question told us this is 15 degrees. And then if I add 15 and 160, I get 175. So I only need 5 more to get 180. And because this is a triangle, okay? And we know we want to find x, and we know this is 2. So I'm going to use the rule, the sine rule, okay? So big B comes to small b. Big D comes to small d. Big A comes to small a. A is not going to help me because I don't want A. I want X here, which is D, okay? So B and D, B will help me because I have two numbers. I have the angle and I have the side B. And because D, I have the angle here, I need the side this. So I just write sine D over small d is equal to sine big B over small b. That's what is called the sine rule. Okay? Now, sine D is 160. So sine 160 over x is equal to sine 5 over 2. Then I will do butterfly method. I will do this and this. Okay? Writing too big. I'm using all my space. So here will be x sine 5 equals to 2 sine 160. I want x, I will divide sine 5 over sine 5. This goes away. I put all this in the calculator. I should get 7 point what? 7.8. 7. Put it in the calculator. Let's see. 2 sine 160 divide by sine 5. Yes, I got 7.848, or 1 to the nearest 10th. I circle this, I underline that. It's the same answer that I got with the other steps of work. I keep telling you, you have to make the connections. You have to make the connections. This is an easier way than the other one. That one has too much steps, which is still okay. You still need to know how to do math. Okay? Same way. I mean, different way, but same answer. Okay? All right. Describe a way you can estimate the height of an object without using trigonometry. Explain your reasoning. So you can use the 1990 degree, the 45-45 triangle, or the 30-60-90 triangle. Describe a way you can estimate the height of an object without using the trigonometry. So you know, when you're estimating, you have to use right triangles, okay? So that's one thing you should know. When you want to estimate the height of an object, the triangle that you should draw, or the shape you should think about, is the 90-degree triangle, okay? And the 90-degree triangle that we can use without using trigonometry or calculator are the 45-degree 90 triangle, or the 30-60-90 triangle. Because you know this is x, this has to be x square root of 2. And you know that this is x square root of 3, this is x, and this is 2x. Okay? So you don't need to do SOHCAHTOA, or you don't need to use your calculator to find the height. You'll just use the rules of the special triangles. So you will write here, if the angle of depression, okay, and elevation make the two special right triangles, that is 45-45 degree 90-degree, and 30, 60, 90-degree triangles. Okay, I can use their rules. I can use their rules to know the height, to estimate the height of an object. Okay, without using trigonometry. Without using trigonometry. And this means without using SOHCAHTOA. That's what that means. All right. This is just SOHCAHTOA. But now we want to find angle, of B. So this is adjacent and this is opposite. So you write SOHCAHTOA. Adjacent and opposite is tan. So you want angle B, you write tan. The minute you see angle B, write tan inverse. Do you understand? I mean, write the trig, whatever you chose. Okay? So here you choose tan, right angle B equals to tan inverse. And what is tan inverse? We'll do here opposite over adjacent because that's tan. Then in your calculator, put all this in your calculator. This is tan inverse. Press shift on your calculator, then press tan. Then your number is who? Opposite is 14 over 8. Like that. After you do that, you should get 60.255. And then that means to the nearest tenth, circle, underline, add. Our answer is 60 and 3/10 degrees. Because it said angle B. So lazim, you put degree. Okay, the unit for angle is degree. Again, the question says find angle. How do I know? Ishara for angle. I write here angle B. That's what I want. Then I decide who is this to be, who is this to be. I go to my trig. I see it is tan. Then I will write here tan inverse because I want angle. Tan inverse. And then I write what this is here, like this. And then I replace with my rakam. Okay? All right. I want angle B. Who is this to angle B? Hypotenuse. And who is this to angle B? Adjacent. So that will be that will be cos. So cos inverse adjacent over hypotenuse. Cos inverse adjacent is who? 25. Hypotenuse is who? Is 30. Put all this in your calculator. You should get 33,557 to the nearest tenth. Your answer is 33 and 6/10 degrees, and you box your answer. Angle B, this is adjacent, this is hypotenuse, so we'll do cos because okay. So angle B equals to cos inverse adjacent over hypotenuse, cos inverse 7 over 39. And that should give us how much should this give us? Okay. Shift cos fraction 7 over 39, close bracket. 79 and 6/10, 66. to the 10th, we are adding, our answer is 79 and 7/10 degree. You box your answer, okay? Angle T, this is adjacent and this is opposite. So this is tan, because so to okay. So angle T equals to tan inverse opposite over adjacent. (14 square root 3 over 34. Okay. Shift tan fraction 14 square root 3 and down here 34. Hey. Okay. Why? F shift. Okay. Fraction 14 square root 3 and this is 34. Okay. So this gives me 35. 496. What 10th? Now, one thing you have to remember. The answers to these questions will always be less than 90. If you get more than 90, mushkila. You did something wrong. The answer to these questions should always be less than 90. Because remember, we said this angle and this angle will be less than 90. They must be. They cannot be more than 90. Because this is 90 and both of them, when you add them, you should get 90. So if you add this, you should get 180. Okay? So if you get a number more than 90, you did something wrong. Okay? All right, we want T. This is hypotenuse and this is opposite. So that will be sine. So T equals to sine inverse opposite over hypotenuse. Okay, sine inverse 7 over 18. Okay. (22 and 9/10 degree). Okay. So this we want T, this is adjacent, and this is hypotenuse, so that will be cos. So angle T is cos inverse adjacent over hypotenuse, because we are looking at T. And this is opposite 90 degree. Okay, so cos and SOHCAHTOA, how did I know? Because I have here adjacent and hypotenuse, and that is cos. Okay. All right, so cos inverse adjacent is 34 over 87. You go to your calculator, shift cos inverse fraction 34 over 87, and that should give us 66. And to the nearest tenth. Oh, now this is interesting. Aha, so if you add 1 here, it becomes 10. So you will write 0, and then this becomes 7, 67 to the nearest tenth, so 67 degrees. There you go. Hi. Oh, this is a different question now. Well, similar, but has more steps, more work. Solve each right triangle. Okay, so you know a triangle has 6 parts. So draw your jadwal. Yeah, I always like jadwal. Here, I'm going to write angles. And here, I am going to write sides. Because that's what it means. Find everybody. Round the side measures to the nearest tenth. This should be to the nearest tenth. Angle measures should be to the nearest degree. Nearest degree. What does that mean? Whole number. Okay? That's how I know. Okay? I have 3 angles. One has to be 90. So I start with that. Angle F is 90 degrees. Angle H is 32 degrees. So which angle I don't know? I don't know angle G. Angle G is 180 minus 90 minus 32. Just like that. And I found my answer. 180 minus 90 minus 32 gives me 58 degrees. So this is what I solved. There you go. I box it. Then I come here to find my sides. I know GF is 11. So I need to find HF and I need to find HG. Okay? So I will box this because this is my answer and this is my answer. Okay? Now, how do I find HF? I will use SOHCAHTOA. I'll use trig ratios. So SOHCAHTOA. Now, I have 32. This is opposite. And I want to find adjacent. Opposite and adjacent, I'll use tan. Okay, so then I will write here. Tan 32 will give me opposite over adjacent. So tan 32 degrees will give me opposite 11. Okay, over adjacent HF. Okay, all right, so I put this over 1 and I do butterfly method. Okay. Okay, so I write here HF tan 32 is equals to 11 times 1. Then, since I want HF, I will taqsim with tan 32. Tan 32. This goes away. HF is 11 over tan 32 degrees. Okay? So in the calculator, I will put I put fraction, then 11 over tan 32. I close my bracket and my answer is 17.603. Then the question told me to the nearest tenth. So circle 6, underline 0, 17 and, no, who is this? HF, yes, 17 and 6 tenths. Then to find HG, I will use Pythagoras theorem. Okay. But if I want, I can still use this. But this is too many steps. So Pythagoras theorem is less steps. Hg is C. So C equals the square root of A squared plus B squared. So then what do I do? So this is 17 and 6/10. So 11 squared plus 17 and 6/10 squared. I put all this in the calculator one time. So square root 11 squared plus 17.06 squared. 20.2. So here is 20.298. Circle, underline, add 1, 20 and 3/10. 20 and 3/10. And there. So whatever I have put in the box is the solving. That's how it is. And then units, because it's length. Units, units, units. Because we don't have meters or miles or kilometers, centimeter. But here our units is, remember the units for angles is degrees. So lazim you put degrees, okay? Aye. So we do this one. This one is hypotenuse. We want to find, doesn't matter. You can find this or you can find this. So let's find adjacent. So we use cos. Okay. So, so we have adjacent. We have hypotenuse and we want adjacent. Our general first. Okay. Here we're gonna do angles. Here we're gonna do sides. Here we need whole numbers. Here we need tenth. Okay. And we should have 3 numbers on each side because we have 3 angles and 3 sides. So who are my angles? X, which is 90 degrees. Start with the 90 degree. Then start with the one that has been given, angle Z, which is 57 degrees. So angle W equals to 180 minus 90 minus 57, which should be 3. Yes, 33 degrees. And you box your answer. Then here, which side do you know? You start with the side that you know. So you know WZ is 18, okay? So now you want to find XZ and you want to find XW, just like that, okay? And now you know these are your answers, okay? So we said we're gonna use that. So we're gonna write here cos 57 equals to A over H. Cos 57 equals to A over 18. To get A, you multiply 18 on both sides. This goes away, so you write here A equals, actually, don't write A, it is XZ, because that's what you want, XZ, so that you remember what you were solving. So now you put this in the calculator. Eighteen cos 57. 18 cos 57 gives us 9 shown ones to the nearest tenth. So this is 9 and 8/10. Then we use Pythagoras theorem. So this is C and this is 9.8. So that's A. We want B. So B equals the square root of C squared minus A squared. C squared is 18 squared minus 9.8 squared. Put that all in the calculator. 18 squared minus 9.8 squared. That should give you 15.098. Circle, underline, add 1, 15 and 1/10. Units, units, units. Okay. Here we can start with the side. This one is easier. Even the angle is easier. Here we don't have to do too much. No. We don't have both angles. So we cannot start with angles. But angles, this is whole number. And then sides, this is to the 10th. Okay. So we know we need 3 angles. I know angle L is 90 degrees, but I need angle K and I need angle J. And then on my sides, I have JL, which is 8 units, and I have JK, which is 22 units. So my answer has to be LK. Okay. Now LK will be B. So let's find B. B equals the square root of C squared minus A squared. This is C, this is A. How do I know C is opposite the right angle? So this is A. A is the shorter side of the right triangle. So 22 squared minus 8 squared. If I put that in the calculator one time, square root of 22 squared minus 64 is 20. It is 20.493 to the nearest 10th, 20.5. So this is 20.5. And I put it over here. 20.5. Now I can use SOHCAHTOA. SOHCAHTOA. Who do I want to use? I have hypotenuse and I have adjacent of J. 8 is adjacent of J. So angle J, hypotenuse and adjacent, so I will use cos inverse, because remember, when I want an angle, I should do cos inverse. Adjacent over hypotenuse, which is cos inverse. Adjacent is 8, hypotenuse is 22. So shift cos inverse fraction 8 out of 22, close bracket, 68.67. Question says we want it as a whole number. So this will be approximately 69. Okay. Who is that? J. 69 degrees. So then this one will be 180 minus 90 minus 69. So 180 minus 90 minus 69 equals to 21 degrees. Okay? So there are my 3 answers that I needed. And I have all my 6 answers. 3 angles, 3 sides. Okay, my jadwal. Here we're gonna do angles. And we have to remind ourselves that angles must be whole numbers. And then here we want sides, and the sides must be to the nearest 10th. Okay? And we should have 6 values because the triangle has 3 angles, 3 sides. Who are the angles? So I have angle T, which is 90, and angle S, which is 32. So this means angle R is part of our answer because we don't know it. And we need to find it by doing 180 minus 90 minus 32. And that should give us 180 minus 90 minus 32 That should give us 58 degrees. Then we want to find the sides. We only know one side, so we know RS or SR, which is 7 units. So the other side that we need to know is RT. So we know this is our answer. And the other side that we need to know is ST. And we box it because we know this is our answer. Okay. So now let us find, we have hypotenuse. We can find adjacent. So hypotenuse and adjacent, that will be cos, because so ka to a. So cos is the one that gives us adjacent and hypotenuse. Okay. So we will write here cos 32 degrees is equals to adjacent over hypotenuse. Cos 32 equals to ST over 7. To get ST, I will multiply both sides by 7. 7 and 7 goes away. So we write here ST equals to 7 cos 32 degrees. And I'll go to my calculator. 7 cos 32. Close my bracket. I got 5936 to the nearest tenth. That should give me 5 9/10. ST is right here. I will put it here. Make sure what you're solving, you put it in the right place. Because if you put it here, it will be wrong. Then I will use Pythagoras theorem. This is C, this is B. I want A. A equals the C squared minus B squared. Square root of C squared minus B squared. C squared is 7 squared minus 5 9/10 squared. This is 49 minus 5 9 squared. I put it in calculator. Square root of 49 minus 5 9/10 squared. That should give me 3.76 like this to the nearest tenth. So this is 3 8/10. Like that. Okay. How many of these questions do I have? 2 more. Okay, this is hypotenuse. Adjacent to B. Okay. Angles, all sides, tenth. How do I know? Side, tenth, angle, degree. To the nearest whole degree, to the nearest degree. Then I make my jadwal into 3 rows. Angle C is 90. Angle B is 25. Angle A is 180 minus 25 minus 90. That should give me 75, I think. Or 65, something like that. 65. I box my answer. Okay. I know AB is 12. So I want to find CB, which should be less than AB, because AB is the hypotenuse. So the answer for CB has to be less than AB, and the answer for CA has to also be less than CB. That's also how you check your work. So if these numbers don't match what you just said, You did something wrong. You did something wrong. Again, we said CB has to be greater than 12. Has to be less than 12. So if we get a number here that is bigger than 12, we did something wrong. We also said CA, it's the smaller. So it has to be both smaller than AB and smaller than CB. So if our answer that we get does not match what we just said, problem. So we're going to use cos because we have adjacent and hypotenuse. That's even easier. Use cos. Cos is easy. Cos B is equal to adjacent over hypotenuse. You want adjacent, so you're going to multiply. So you're going to write adjacent equals to hypotenuse cos B. Hypotenuse is 12, cos B is 25 degrees. Put this in the calculator. 12 cos 25. Close the bracket. That's 10.87. 10 and 87 hundredths. That becomes 10 and 9 tenths. What am I doing? 10 and 9 tenths. Who is this? CB. 10 and 9 tenths, because that's adjacent right here. Okay, CB. So you don't forget. Then do Pythagorean theorem. So you want A equals square root of C squared minus B squared. Who is A? CA. CA equals to 12 squared minus 10 and 9 tenths squared. Put all this in the calculator. Square root of 144 minus 10 and 9 tenths squared. That should give us 5.08 to the nearest tenth. 5.0 is 5, so just 5. This is approximately, oh yeah, because we rounded. Approximate. Make sure these are approximate units. Approximate. No, this was there. This is equal. This one is equal. This one is approximate. Okay. Approximate. 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 Okay. Okay. Yes. Okay. Let's find hypotenuse. So we use cos. We cannot do that. We cannot use cos. Here we'll have to use opposite. So this is tan. Okay. Opposite, and we can use sine or we can use tan. Which one do you want to do? It's up to you. Okay, so I will use tan. Okay. Okay, let's draw our jadwal. We'll draw a jadwal over here. Let's draw our jadwal. So this is angles, and this is sides, and this is whole, and this is tenth. And I know I should have 3 measures of angles and 3 measures of sides. So angle, I know angle Q is 45 degrees, and I know angle M is 90 degrees. So I know I need to find angle N. which is 180 minus 90 minus 45, which should be 45 degrees. I don't even need to use SOHCAHTOA. I told you, life is very easy. This should be 18. Remember, 45 degree angle. This is x, this is x, this is x square root 2. So if this is 18, this is also 18. So very, very easy. Very, very mindful. Okay. So QM is 18. MX is 18. Actually, we know. So we start with what we know first. Let's start with what we know. So we know MN because the question gave it to us 18 units. And we found QM, which is 18 units. And this is an answer because we found it. And then now we want to find what? So this will be 18 square root 2. Okay? So we want to find Qn. Qn equals to 18 square root 2. And because we've been told we need to round to the nearest tenth, this will be 25 455. Circle, underline, add. 25.5. There you go. Units. Okay. Kalas. You found your 3 answers without too much work. See? I told you. Math is fun. If you know Kanun, math is definitely fun. Definitely fun. Okay? Math is definitely fun. Now we go here. Okay. So this is the right up, and this is the right down. This is, what am I doing? Today I don't know my right and left. So this is my left up and my left down. And this is my right up and my right down. Okay. So I'm going to do left here. I'm going to do right here. And I'm going to do up here. And I'm going to do down here. Okay. Okay. My left up is M. I don't have it. My right up is 26. My down left is 8. My down right is 12. And I do butterfly method. 12m equals to 26 times 8. Divide by 12, divide by 12. M is whatever this is. When you put this in the calculator, are we rounding to the nearest tenth? Okay. So you should get 208 over 12. And then that should give you 17.3333. Like that. And then to the nearest tenth, you circle this, underline that. Your answer is 17 and 3/10 units. Units, and you box it. Okay? Now let's do this one. This is left up. This is left down. This is right up. This is right down. So left. Okay, let me use a different color. Okay. So here we will do left and right. And I'm going to do up and down. So your left is 20 over 7 and 24 over x. Butterfly method. 20x equals to 24 times 7. Okay? Then that should give you divide by 20, divide by 20. X equals to 168 divide by 20, which gave us 8 and 4/10. And you box your answer. Okay? This is very easy. You want to find X, but you know all this. So let's find XA. So XA is equals to the square root, because this is the triangle here. So right triangle. So this is B and this is C. So you want to find A. B squared minus C squared minus B squared. Or you can just find BA squared minus BX squared. Okay, so the hypotenuse is BA, which is 12 squared minus 8 squared. This is 144 minus 64, giving us square root of 80. And then when you simplify this, yes, you should get a decimal that is 8.94. Then to the nearest tenth, so answer should be 8 and 9/10. But the answer wants XC. Now we found XA from here to here, which is 8.9. So now we find XC equals to CA minus XA. CA is 14 minus 8.9, and that should give us 5.1 units. And this is our answer. The question wants EY. Okay, so what can we do? Hypotenuse over height. Okay, so we're going to have here left triangle and right triangle. Okay, so we're going to compare hypotenuse and height. Hypotenuse is BA of the left triangle, and the height of the right triangle, the height of the left triangle is BX. And then hypotenuse of the right triangle is 8. No, it's the half first before we write the rakams. So DE or ED, because we are taking corresponding sides. So B corresponds with E and D corresponds with A. So ED, and the height is EY. Okay? Now let's put our numbers. BA is 12 and BX is 8. ED is 8. EY is what I need. I do butterfly method. So we have EY, 12 EY is equals to 8 times 8. Okay? To get EY, I will divide by 12 on both sides. So EY equals to 64 divide 12, and that should give me 5.333 like this, and to the nearest tenth, I am not adding, so my answer should be 5 3/10 centimeter, because that's the unit, centimeter. Okay? Oh, okay. Paragraph proof. What's happening here? I have been given RTS, so you start that. I have been given that triangle RTS is similar to triangle EGF. And line TA and side TA. No. Should I call them angle bisectors? Oh, yeah, they're already here. So, and TA and GB are angle bisectors. Okay. So, angle R, so angle R and angle E must be congruent. This angle must be congruent to this angle. Okay. And angle RTS, this angle, and angle EGF, this angle, are also congruent. And angle RTS and, okay, so why did I put angle? And RTS with the angle there, angle RTS and angle EGF must also be congruent, must also be congruent. And because of that, that's why we want to prove we can only use this if whatever we are saying is congruent. Okay. So, so if these two are equal, and TA is a bisector, so this is nous of this. Yes, so I can say also, okay, also, I know that half of angle RTS is congruent to half of angle EGF. Okay? Which means RTA, this here, okay, must be congruent to EGB, this here. Okay? Okay. This means that angle RTA is congruent to angle EGB. EGB. Okay? All right. So because I said all this, it means triangle RTA is similar to triangle EGB. Okay? So, okay. RTA, this triangle. Because how do I know? You only need two angles to be the same. We already said this angle is the same as this angle. And we've said this angle is the same as this angle. So we're going to use AA similarity, okay? By AA similarity, Hence, TA over GB equals to RT over EG. Okay? So why did I say this statement? Because I know this angle, I need only two angles in a triangle to be, two corresponding angles to be congruent. So this R corresponds to B and they are congruent. And this T here corresponds to this G here, which makes them congruent. Now, because these two angle pairs are congruent, then I can use this proportion. Okay? Two-column proof. Okay. So let's do two-column proof. How do I do this one? Here is statement. Here is reason. Okay. So here we have triangle ABC is similar to triangle RST. Write all this here. Write all this here and write given. Okay. Then D is the midpoint of CB. D is the midpoint of CB. And what else? U is the midpoint of TS. U is the midpoint of TS. Median. That's what a median does. Median goes to the center of the line, to the midpoint of the line where it is going to. That's why it's called a median. Okay. All right. Then that means CD is equals to DB. Yes. So if this is in the middle, this is equal to that. CD is equals to DB. Okay. And then TU is equals to US. So midpoint something. There should be midpoint formula or midpoint theorem, something like that. Midpoint. Okay. And then let's draw another jadwal. Let's make this like this. My line stop here. Okay, let's draw another jadwal. So we're gonna go statement and reason. So we're gonna be AB over RS. They are corresponding. This corresponds to that. Okay, is equals to CB. This corresponds to this TS. Okay, then how can I write CB? How can I write CB? We know that CB is the same as CD plus DB. And then how can I write TS? We know that TS is TU plus US. So, and what does that call us? Here, the reason why we wrote this, similar triangles. Here, the reason we wrote this, addition. Addition what? Something, segment or postulate. Addition postulate for what? Addition postulate. You can just write addition. That is fine. Addition of midpoint. whatever, of segments. Yes, you can write addition of segments because this is a segment here and here. So addition postulate segments of segments. Okay. Then now you can substitute. You're going to put this here and you're going to put this here. So you're going to write AB over RS is equals to CD plus DB over TU plus US. Then you know that CD, whatever number you write here is the same you will write here. So replace CD with DB here. Use this canon. So where you have CD, you're going to put DB. So you're going to write AB over RS equals to DB plus DB. And then we know that TU is the same as US, so you're going to write this as TUS plus US, US plus US. Okay? Now, in math, what do we say when we have this? Do I even have space? I don't have space. Okay. So all this is substitution. Okay? Let me do something. Okay. Let me add a new slide here. Okay. All right. So now we are still doing our slide. So here would we have statement and then reason. Okay. So I had said that AB and RS is the same as CD plus DB. Okay. And then I also said that RS is the same as TU plus US. I should have brought the picture on this side. Now, as you look at the picture, we see that AB, so we will substitute here. We had an equation over there saying, at the back over there, we had an equation saying that CD is equals to DB, okay? So I'm gonna write here DB to replace this CD, and then this DB is for here. The same thing we had there on the previous slide, TU is the same as US. So we're gonna write here US plus US. Now, in math, when we repeat the same half, we can use the Harakam 2. AB over RS means 2dB. And this becomes 2US. Okay? Now, this 2US and this 2US goes away. So now we would write here AB over RS equals to DB over US. All these people are substitution. That's the reason. Okay? Then we can continue. So therefore, now I have finished with the sides. I can do angle B is equal to angle S, okay, in similar triangles. So therefore, triangle ABD must be similar to triangle RSU. Okay, so here similar triangles. Okay, so, and because I said all that, so this will be AB. I have proved that AB over RU is equal to AB over RS. And then here you will write here definition of similar triangles. Okay. Two-column proof. Oh, okay. All right. So let's do this. Statement is on. Make sure you write all this here. Okay? So we should use similar triangles, and then that means we should write proportions. So here I can say that AD is equal to E AD is proportional to, okay, here, okay, and then we should do EC and this, okay, EC, what am I writing? EC, and then here is DB, so I'm doing, here is down, and here is right, okay, and then here, okay, then I did, yeah, okay, then I did short and long, short and long. Okay, so the long for this one would be CB or BC, doesn't matter. It matters because it has to match. The half has to match. Okay, like that. So then triangle proportion. Proportion. Okay. Triangle proportion theorem. Kanun theorem. That's the reason why I wrote that. So angle 1 must be equal to angle 2 because this is a median. Is it a median or a bisector? Bisector. This one CD is a bisector because it's not a median. This one is smaller than this. Because CD is a bisector, okay, angle 1 is equal to angle 2. And then you say because CD is a bisector. Okay. Then I have parallel lines here. Let me erase this. So this line here is parallel to this line here. And this is a transversal. And therefore, this angle and this angle, angle 1 and 3, must also be congruent because they are alternate interior. Angle 1 is equal to angle 3, alternate interior. How did I know I have a parallel? It says there. I did not make it up. The question told me. Okay, interior angles. Now, let's continue. So therefore, this angle 2 should equal this angle 2 because they are corresponding angles. Yes. See, if I go with my line here, and here is my transversal, see, This angle here must be the same as that angle there. Using, okay? And they are corresponding. So angle E is equal to angle 2 because they are corresponding angles. Very good. Okay? Now, if angle 1 is equal to angle 2 and angle 2 is equal to angle 3, if angle 1 is equal to angle 2 and angle 1 is also equals to angle 3, it makes angle 2 also equals to angle 3. Transitive property. Okay? Statement. Reason. Angle 1 is equals to angle 2, which will also be equals to angle 3. So therefore, transitive property. Okay? Then I know that EC and AC, very good. Now, we said angle 3 is equals to angle 1. So, they are equal. So therefore, and we also said angle 1 is the same as angle 2. So, and we said angle 2 is the same as angle E, right here. Yes? So therefore, this triangle EAC is isosceles. So that means this is equal to that. So this angle here should also be angle 3. Okay? So we are going to say angle 3, or let's talk about sides. Line AC should equal line EC. And then isosceles triangle. Isosceles triangle. Okay? Because two base angles are the same, these two sides, the two shorter sides must also be the same. Okay? Now, we said they're congruent, then you can write them as an equation, EC. Okay? Congruent sides of a triangle, of an isosceles triangle. Okay? So, and that makes it, we can use now this proportion AD over B equals to AC over BC by substitution. Just like that. Okay? Okay. Here, this is very easy. A graph a rectangular solid. That means your picture should be a rectangular prism, like that. Like that, like that, like that, like that, like that. And then it will be like that. That's what it's saying. We should see this picture over here on this graph. Okay? Now, we need 8 vertices. 1, 2, 3, 4, 5, 6, 7, 8. The first one has already been given to you. It says the origin. So always label. You need 8 different points. 1, 2, 3, 4, 5, 6, 7, 8. Then follow the Kanun. 0, 0, 0, then x 0 0, then 0 y 0, then 0 0 z, then x y 0, then 0 y z, then x 0 z, and then x y z, like that. Then now put your numbers. This one stays the same. This stays the same, 0 0 0. And you remember this is x, this is y, this is z. So this becomes 2 0 0. This becomes 0 1 0. This becomes 0 0 5. This becomes 2 1 0. This becomes 0 1 5. This becomes 2 0 5. And this becomes 2 1 5. Just like that. Now plot your points. 0 0 is here. Okay. Then you're going positive on x, 2 boxes, which is here. That is 2 0 0. Okay. You can label them. So if this is A, this will be B, this will be C, D, E, F, G, H. How did I know this is A? The question told me. Okay. So I labeled going up. Okay. So who did I just label? I labeled G and I labeled H. Okay. So now I want to do 0 1 0 on Y. Yes. So that will be here. That is F. And because I used 2 boxes, so I should use 2 boxes. So who is this? 2. I didn't go on F. I mean, I didn't go on Z. So this is 2 1 0. So this is D right here. Then I connect with a ruler. Okay. Now I should go up 5. I go 5 from every point. 1, 2, 3, 4, 5. Okay. Now who is that? This is 2 on X. I didn't go on Y and then I went on 5. So that is B. 2 on X. I didn't go on Y and then I went 5 up. That is B. Then I will do 5 from here. 1, 2, 3, 4, 5. So I did not go on X. I did not go on Y. I only went on Z. So that's this one here, E. So that is E. Okay. Then I go here. 1, 2, 3, 4, 5. Okay. How did I do this? I went 1 on Y, so I didn't go on X. 0X, 1Y, and 5 up. 0X, 1Y, so that is C. So this is point C. And then I just continue. This will be the next point. And which half is that I have not put I have used G, I have done H, I have done B. Is it B or D? D. I have done D, I have also done B. Okay, so that has to be A. This is A. This is A right here. Then I connect them like that. And then, let me take this, let me do the red. Now I join. This goes here. This goes here. And this goes here. Now, how do you check? Make sure you've used 5 boxes. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here is the Kanun. Use this Kanun to get your points. Yes? The most points for your mark will come from here and from your drawing. Okay? Let's try this one. We have said the Kanun will be, first you write 1 to 8, 3, 4, 5, 6, 7, 8. Then label that P, Q, R, S, T, U, V, W. And we know this one must be 0, 0. This is the Kanun. This one will be X, 0, 0. This one will be 0, Y, 0. This one will be 0, 0, Z. This one will be X, Y, 0. This one will be X, 0, Z. This one will be 0, Y, Z. And this one will be X, Y, Z. Then you change them to your numbers now. Change them here. So this one stays the same. It doesn't change. That's your W. Your X is -1, and then 0, 0. Then your U is 0, 4, 0. Because remember, you're following X, Y, Z. Then 0, 0, 2. Then X is how much? -1. Y is how much? 4. And then this is 0, -1, 0, 2. And this one is 0, 4, 2. And this one is all of them. Just like that. Okay. So let's start. 0, 0. Not a good color. Let's find a better color. Okay. 0, 0. And we call 0, 0 who? W. Then -1, 0. So let's label on this side. Remember, X negative is over here, up. This is X negative. This is X positive. You must know how to label your graph, okay? Your coordinate plane, please, please, please. This is X, this is Y, this is Y negative, okay? All right, so 0, 0, -1, 0, 0 will be here, and that is V, okay? Then 0, 4, 0 on Y, 0, 4, 1, 2, 3, 4, right here. That is our U. And then, so we finish this here, okay? And we put our picture. Now, who is this? I went 0, no, I went 1 on X, negative. So -1, And then I went 4 on y and 0. So this is S. This is S. Okay? Because all I did was go -1 on X and 4 on Y. Okay? So that is S. So I have done S. I have done W. I have done 0. I have done -1, 0, 0. I have done V. And I have done U. Okay? So now I need to go up 2 boxes. So my first 2 boxes is here. My second 2 boxes is there. The other 2 boxes is here. From U, I can 1, 2, and then from S, 1, 2, right here. And then I join. And then this goes here, and this goes here, and this goes there. So now you can clearly see I have 2 boxes on every height. Do you see that? And there is my picture. Now I label. Who is this? -1. I didn't go on Y, but I went up. So -1, 0, 2. -1, 0, 2 is R. That is R. I didn't go on X, but I just went on. I didn't go on X, I didn't go on Y, but I went on Z. So this is 0, 0, 2. 0, 0, 2, this is T right here. Where is R? I have done R. Now I need to label Q. I went 0 on X, okay, which is here. Then I went 4 on Y, which is here. Then I went 2 on Z. So this is Q. Okay, so I have done Q, so this has to be P. Okay, and you label. If you label your picture correctly, there. Bring colored pencils so you can do this correctly for yourself. So you can see clearly. Carry colored pencils or carry 2 different pens. Then I have solved. So I have checked that I have solved my red points and my green points. And there. Practice this by yourself. Okay? Practice this 3, 4 by yourself. Now let's do distance. Distance equals the square root x squared, x2 minus x1. It doesn't matter. You can do x1 also. But you have to do for all your halves. So this is, we will label, wait, y1 plus z2 minus z1. Okay. So this is x1, y1, xz1, x2, y2, z2. 2 minus 0 squared plus 4 minus 0 squared plus 3 minus 0 squared. 2 squared plus 4 squared plus 3 squared. 4 plus 16 plus 9. 25, 29. Question did not tell me to make it decimal. So this is my answer. I stop over there. Same thing here. X, Y, Z, 1, 1, 1. X2, Y2, Z2. Square root. X2 minus X1 squared plus Y2 minus Y1 squared plus Z2 minus Z1 squared. X2 is 9 minus -2 plus 0 minus 5 squared plus 4 minus -1 squared. This is 9 minus 2 is 7, 7 squared plus -5 squared plus 5 squared. 7 squared plus 49 plus 25 plus 25. Come 50 plus 49, 99. Okay, so my answer is square root of 99 units. That's your answer. Okay. Determine the distance between each pair of points. Do this by yourself. Should be easier. BCDF is a square. FD is 55. Find each measure. Find BC. This should be also 55. Opposite sides of a square are congruent. BC is equals to FD, which is equals to 55 units. Find CD. CD is also equal to 55 units because consecutive sides. Here, opposite sides. Opposite sides of a square are congruent. Here, consecutive sides. Question told me, so that is important. Consecutive sides of a square are congruent. BCDF is a square. Square, very important. FD is 55. So this should be 55. This should be 55. This should be 55. Find each measure. Find GD. I can use 45, 45, 90. So this is 45 degree, 45 degree, 90. So I want GD. So this is X. This is X. This is X square root 2. So I will write here F or GD. No. FD is equals to hypotenuse. And then FD is equals to X square root 2, which is also equals to 55. So then I will taksim because I want X. Okay. Square root 2, square root 2. This goes away. So X equals to 55 square root 2. In math, the square root can never be in the denominator. So you need to rationalize your fraction. So 55 over square root of 2 becomes, we want it as a decimal. So yes, press SD. So this will become 38,890 to the nearest tenth. So our answer is 38 and 9 tenths units because it's length. And that's our answer. If I didn't want to do that, I could do Pythagoras theorem. So I will say GD is equals to BD equals to BD divided by 2. And how do I get BD? BD is BC squared plus CD squared. And then I find the square root and I divide by 2. So that means 55 squared plus 55 squared, and then I divide by 2. And if I do that in the calculator, so fraction square root 55 squared plus 55 squared, and I divide that by 2, I got the same thing, 38.89. And then I circle this, I underline that, I add 1, 38.9 units. Invokes my answer. Okay? So either way, you decide. So you have to remember when you see the word square, use 45, 45, 90 triangle rule, or use Pythagoras theorem. If BCDF is a square, FD is 55. Find BD. I'm going to use Pythagoras theorem. So BD, which is C. Why is it C? Because it's opposite this 90 degree. So BD equals the square root of BF squared plus FD squared. Square root of 55 squared plus 55 squared. Okay? Square root of 55 squared plus 55 squared, 77.78. Round to the nearest tenth, add 1, 77.8 units. Okay, WT is 3, this is 3, this is 3, this is 3, because of the word square. So this will be 3 square root 2, 3 square root 2, because I'm using 45 degree triangle. ZX, so ZX equals to XT plus TZ, which is equals to 3 plus 3, which is equals to 6 units. XY is 3 square root 2 because I used 45, 90 triangle rule. If I don't want to do that, I can do Pythagoras theorem. XY equals to XT squared plus TY squared. 3 squared plus 3 squared, and then that gives me 9 plus 9, which is the square root of 18, which should give me 3 square root 2. Yeah. Okay. So either way, you decide which one you want to use. Put units. Put units. Okay. If WT is 3, so this is 3, this is 3, this is 3, this is 3, this is 3 square root 2, this is 3 square root 2, 3 square root 2, 3 square root 2. Why am I finding sides? Because I want to find angles? Okay, I also know that this is 90, this is 90, this is 90, this is 90. Let me use a different color for the angles. Okay. This is 90, this is 90, this is 90, and this is 90. All diagonals are bisecting the vertices, so this will be 45, 45, 45, 45.